All right, so we've been talking about rivers, tributaries, streams. We've been talking about watersheds, and we've been talking about river basins. So all surface water up to this point, and now we're going to switch gears and go to groundwater. Groundwater is a major source of drinking water for a lot of people. And you think, dude, why would you want to drink water that's in the dirt? But we're going to be talking about where we get our drinking water from. It's not just we go out to the puddles and be like, whoop, drinking water, yay! There's a specific way we get this water, and it's some of the freshest water on the earth. So groundwater, I titled this Fresh Water Sources Continued, because we started this on the previous page when we talked about rivers. And I will tell you, hydrosphere genuinely takes pretty much the whole quarter. Most of our third quarter is going to be water. A big chunk of it is oceans. But we need to get through fresh water first. And the bonus part about it taking so long is that it's not that it's a super ton of information. It leaves a lot of time open to do hands-on laboratory investigations. So we will be analyzing water sources. We will be building filtration systems. We'll be doing all kinds of hands-on stuff. Some of it we'll be doing next week. But we got to get the information down pat first. Yes?
When's our next project?
I haven't decided yet. I got a few ideas floating around in my head. And a lot of it depends on makeup days and snow days.
Do you think we're gonna do something on this?
I don't know if we're going to do an at-home project or if it's going to be more in-class project. Whereas in the first quarter we had, more at-home where you guys had to do it and bring it back, the superhero element project. Most of what I want to do involves data collection that we do in class, because I'm going to borrow probeware from the university again, and we're going to use those pH probes again. We're going to use dissolved oxygen meters and turbidity sensors and all that good stuff. So that will be, of course, something I can't let y'all do at home. It'll be something we do in class. But as far as a project, I may wait until after the hydrosphere for y'all to do something at home, which I don't think y'all are going to hate me for. No? Unless y'all want. That's what I'm saying. Y'all probably got to do it in class. So for now, we'll stick to in-class stuff. And then if I feel like there's something that y'all would really enjoy, that would bring your grade up, and that is useful to what we're learning, then I'll make that decision. But I need to know what they're going to do with those makeup days first, because that's going to affect how much class time we have. All right. The groundwater. We have infiltration of water. That's part of our water cycle. It rains, water seeps into the ground, infiltrates into the ground. And it does that because it's filling spaces in between sediments, these pores, these holes. We can't really see them just looking at the ground. It just looks like ground. But if you were to look at it up close with a magnifying glass or a microscope, you would see that there's spaces, tiny little microscopic spaces in between sediments. And that's where the water goes when it infiltrates in the ground. It goes in those spaces, and it keeps going down until it can't go down anymore. And we're going to talk about where it stops at. So when you hear the word pores, that means holes. Yeah, rhyme's right, rhyme's wrong.
Period.
Y'all want me to stick my head in and go, you go, girl? No, I will get in trouble. Now, depending on how many pores or holes sediment has, depends on what type it is. So, looking at the soil of my different plants up here, I have potting soil for 3 of the plants, but I don't for this plant. And I would like to say that I did my research, and scientifically, this soil is better for this plant, but the real answer is I ran out of potting soil. So I dug up dirt from my yard and put it in there because I'm too cheap to go buy more dirt. But that makes a good example for us because the potting soil is more porous. There's more space in these sediments. So when I pour water in here, which I don't do often enough because this thing says it's dry, that's my bad. But when I do pour water in there, it gets soaked in or infiltrated very quickly. It doesn't stay on the surface very long. This plant, you can even look and see that the dirt looks different, and that's because it's a lot of clay mixed in. In North Carolina, we have a lot of clay in our soil. So when I pour water in here, I gotta pour it a little bit at a time. I gotta pour it, and I gotta wait for it to infiltrate, pour a little bit more, wait for it to infiltrate. Okay, that's because it's not as porous.
What if you just pour it all?
It's not. I did that, and that's why there's water damage on my shelf here, and it's peeling back because I went group and it fell over on the sides because it didn't have time to infiltrate. I'm not very patient. That's why my plants usually die. So the fact that they are alive now is a miracle. That ivy plant is actually, I got beginning of last year, and it's still alive. And I'm like, you're still alive. It almost died last year because I put it in front of a window and next to my printer, so it got too hot, and the soil dried out, and it fried in the middle. It was awful. I'm like, no plants for Miss Thomas. Obviously, since the Venus flytrap didn't make it, 4 days into the school year? Y'all were like, where's the Venus flytrap? I'm like, yeah, it died for real. That's like my 4th one, too. All right, so here's a little drawing of what it looks like. If you were to take a handful of sand or something, and you were to look at it under the microscope, it would look something like this. The round balls represent grains of sand or sediment. The dark stuff is water. So when water infiltrates, it gets into these spaces. Depending on the type of the soil it is, it may stay there or it may move along further underground. So have y'all ever been to the beach and you built a sand castle? Every castle needs a moat, right? You gotta protect your castle. You wanna build a moat around the castle, filled with water. So I do, and I do this multiple times like I didn't learn. Build a sand castle, dig a moat. I go get a bucket of ocean water, come back and dump it in. I'd have a moat for like a minute. When I say minute, I mean like less than a minute. It would be gone. It soaks in super fast. My moat's gone. That's because sand is porous. That's why if you have a cactus plant, you want mostly sand. You want very porous water. You want that to infiltrate fast, and you don't want it to stay. Cactus plants can't handle a lot of water. They get too mushy. They've adapted to being without water, so they like water to move through very quickly. Certain grasses, yeah. If it sits there too long, it drowns out the grass, and then when the waters recede, you're left with that nasty brown grass, right?
Yeah, it's like muddy.
It's gross. Some grass does better. Like coastal grass does better. Let me know if I'm moving too fast. All right. There's a word I underlined in that sentence, permeable. Permeable. This is an important word. You will see this many times. The more permeable a substance is, the more water will go through it. Usually that means the more porous it is. So my soil with my skinny palm tree looking plant is more permeable than the clay soil in my ivy plant. Permeability, it's got the word ability in it. Permeability is the ability of water to move through sediment and rock. So if you are permeable, water will be able to move through you fairly easily. So this soil is fairly permeable. Water will go through it pretty well. If you are semi-permeable, semi means a little bit. So semi-permeable impermeable means water will go through you, but maybe not as fast. It won't infiltrate as fast. So my clay soil over here is semi-permeable. Water will go through it. It's just going to take a minute. If you are impermeable, that means you will not allow water to move through you. Thankfully, this table here is impermeable to water. That means every time I water my plant and I make a mess, which I do, and water spills on here, the water will stay there until I either wipe it up or, more likely scenario, I let it dry up and let it evaporate because I'm lazy like that. So if I spill water here, it will stay there until it evaporates. And it will not mess up the wood because the wood here has been painted and it's impermeable to water now, which is good because think about if your desks were not lacquered up so that they were not impermeable to water. Every time y'all spilled water, your desk would rot. What if your car wasn't impermeable to water? Every time it rained, it'd be a real bummer to drive. What if you're a surgeon? You wear those gloves, you're elbow deep in somebody's abdominal cavity trying to save their life. Do you want gloves that are permeable or impermeable?
Impermeable.
You're darn right you do. Ain't nobody want body cavity juices on their hands. Ain't nobody want doctor sweat in their abdominal cavity. So you want gloves that are impermeable to water. You want to make sure that water stays where it's supposed to be. All the fluids stay where they're supposed to be. That's why when you guys do like dissections, and when you're done, you take the gloves off, your hands are all sweaty. That's because those gloves are impermeable. That's not the frog juices and whatever on your hands. That's because the gloves are impermeable, and so it doesn't let the sweat out, so it stays on your hands, so your hands feel wet. Did y'all dissect frogs last year?
No.
We have a summer camp, and we dissect, every year we dissect frogs, we dissect rats, and then sometimes pigs.
Will we ever do it in here?
8th grade science is not a dissection-friendly curriculum. However, I'm working on getting us some owl pellets to dissect whenever we do the food webs and food chains unit in a couple weeks. When I say a couple, probably next quarter. Has anybody ever dissected an owl pellet before? It looks kind of like a dried up piece of poop, but it's not poop. What it is, and it's a sidebar. We're getting off track, but that's okay, real quick. What it is when an owl eats like a mouse, it eats the whole thing. So it can't digest the fur, excuse me, it has trouble digesting bones, teeth. If it eats a smaller bird, the beaks, and whatever, it can't digest that very well. So it builds up inside of its digestive system, and eventually it goes back up. And it looks like this, like, it looks like poop, it looks like a turd. I don't know what to tell you. Everybody's like, it looks like a turd, but it's dry. They dry it out. And inside of it is bones and stuff, skeletons. Really cool. It's like, you can see evidence of predator and prey relations. So I'm working on getting that. They're fairly inexpensive, so I think I can do it. All right, here's another important word for you, saturated. When you have it rain, water infiltrates or soaks in until it is saturated. That means it cannot hold any more water. All the pores or holes are filled. That's it. So if you ever read the back of like a shampoo or conditioner bottle and what, I don't know what they have directions on there, but I guess in case you need directions on how to use it, it says thoroughly saturate hair. That means get your hair as wet as it can get. So this is a good example when we have flash flood. We had a lot of rain. I mean, I feel like we've had a lot of rain since fall, like since early fall.
We
like
have.
I mean, like between the hurricanes and then just the rain. I mean, we had floods just out of nowhere. whenever we have flash flooding, the ground becomes saturated very quickly. That means all the pores are filled with water. The water has nowhere else to go but up. And when it goes up, it floods homes, it floods streets, and it doesn't go away very quickly. It stays around for a while. And saturation is not a bad thing in certain situations. This is another one of those things that you guys need to be aware of when you're buying houses. Or say, maybe y'all will be one of those people that buys a chunk of land that's undeveloped, and you create one of those neighborhoods that people pay like $350,000 a house for.
That would be so good.
I'm just saying. People do it all the time. You need to make sure your land is not easily saturated. Otherwise, the first time it rains, you're going to have some very upset homeowners. Or if you live in an area that becomes saturated